Assalamualaikum and hi. So today we want to present modulus of elasticity and tensile strength of coconut fiber based on composite plate. This is our group member, me, Nur Hafiza, Nur Akila Iriani, Shazwani, Noreli Shafariha, and Nurul Rozairin.
Assalamualaikum and hi, my name is Noreli Shafariha binti Muhammad Irisham and my matrix number is DF200174. Firstly, let me introduce about our project, which is modulus of elasticity and tensile strength of coconut fiber based on composite plates. Composite plates are formed by two combinations of physical materials and chemical materials that have different function. The other materials work together to give unique composite properties. But within the composite, they can easily define the different materials apart as they do not dissolve or blend into each other. When the material joins, they preserve their unique identities and the ingredient may be divided into three categories, which are base, binder, and filler. In this project, the composite materials that were used were coconut fiber and carpenter glue. Combined, it can generate material with characteristic distinct of separate component. As a result, the constituent element become distinct and independent. The new material may be favored for a variety of reasons, including materials that are stronger, lighter, and expensive less than old materials. For the problem statement, it is very challenging in choosing material as there are many choices such as plastic, rubber, aluminium, and more. From a composite that had been suggested based on stiffness and tensile, the selection of the material must be careful as it must be in zero cost. Second, the composite must be sufficient stiffness, strength, and durability. In addition, to make it more durable and stiffer, the composite must be compacted. So, the process of making must be in the laboratory and the student must find the correct laboratory to make sure everything is done correctly. Last but not least, it is difficult in the process of making the composite plates as it must be 4 layers and should not be thicker than 2 mm. Furthermore, the maximum length of this plate is 200 mm and the width is 20 mm. So, the layers must be arranged correctly to make sure the plates stiff and durable. So next, we will move to objective. As you can see, there are 3 objectives in this project. First is to purpose composite materials made from eco-friendly materials. Second, to design and apply a composite plates by using coconut fiber and compress into 4 plies. And lastly, is to investigate and determine the modulus and tensile strength of the composite plates.
Okay, let's move to literature review. For introduction of composite, Lina Mishra 2020 have mentioned the use of composite material derived from renewable and sustainable resources has a variety of benefits, such as enhanced performance due to excellent mechanical properties of coconut fiber, which include high strength, stiffness, and fatigue resistance, as well as decreased weight due to their exceptional strength to weight ratio. Coconut fiber can be substantially lighter than conventional material like steel or aluminium, while yet retaining their strength, durability, energy efficiency during manufacturing, recyclability, and low carbon footprint. For overview of coconut fiber, the water absorbed into the lignocellular surface of the hydrophilic coil fiber apparently prevent an efficient adhesion to the hydrophobic polymer matrix, which also happened in another natural fiber composite by Vasquez 1999. By Montero 210, these consequences in cooperation of coil fiber tends to decrease the mechanical strength of the polyester composite for any volume fraction fiber. There were ways to increase this mechanical properties condition. One of the ways is through selection of thinner coil fiber. Lastly, for tensile strength test on coconut fiber, the tensile test was performed in the Universal Testing Machine UTM in round 1195, and the result on the test is shown in Table 1 by Biswas 2010. As highlighted on the table, for coil fiber length 20 mm, tensile strength 9.2 MPa, tensile modular 1.5 MPa, and flexural strength 31.3 MPa.
Assalamualaikum and hi, I am Suzwani binti Samsul Bahri with number matrix DF220183. I will present about methodology part, which is the process of this project. It will start with the selection of the material, which is all group members refer to the internet and give an idea to determine which materials are the most suitable for this project's objective. We choose coconut fiber because it is eco-friendly and easy to get. After that, the preparation of coconut fiber will be made by splitting up the fiber. Then, we create the design of the specimen by following the project's requirement, which is in the shape of rectangular. Next specimen will be made in size of 20 cm length, 2 cm width, and 0.02 cm depth. Then we split it into 3 again to make 3 layers. To stick the fiber, we use carpenter glue. The final specimen at the end is only 3. When the plate is ready, experiment setup testing of tensile strength and modulus test can be begin and data analysis can be obtained. Data analysis will be focused on strain and stress. Finally, the conclusion can be made by referring to the observation and analysis during the testing.
For procedure experimental testing, first is plate preparation. We choose coconut fiber as recycle item. Firstly, 2 old coconut were shredded until thin to get fiber. The measurement were 20 mm in wide, 2 mm thickness and length 200 mm, and we choose carpenter glue to attach the material. Second, tensile strength. First step, this experiment is to determine the coconut fiber composite plate's tensile strength. Universal testing machine was carefully calibrated to achieve precise measurement. After calibration, the specimen received a preload. This preload ensured that the specimen and the grips were in touch and aligned. Then, the test parameter was set and execute the test to apply gradually increasing force. The loading rate should be carefully selected to prevent early failure. Continuous load were applied to the plate. The corresponding deformation of the specimen was also measured using strain gauge. The test was repeated until either the plate attained its maximum load-bearing capacity. First is modulus of elasticity calculation. The modulus of elasticity is to measure the plate stiffness or rigidity. To calculate it, have to divide the stress, which is force per unit area applied to a material by the corresponding strain, which is deformation per unit length. Second is data analysis. After testing and calculation, the recorded tensile strength and modulus of elasticity value were examined. Then, 2 statistical techniques were used to evaluate the consistency and veracity of the result. The test and calculation findings were then compared to the project requirement.
The differences in mechanical properties among the coconut fiber plates can be attributed to variables like fiber volume fraction, bonding quality, and manufacturing process parameters. Comparing tensile strength and modulus evaluations provide valuable insights into this variation. Plate 1 has the highest tensile strength that can sustain the highest load-bearing capacity among the plates. This result proves that plate 1 is higher in fiber volume fraction, greater bonding quality of coconut fiber and the matrix, and better manufacturing process parameters in curing and post-processing treatments. Hence, plate 1 is the best alternative for application that needed a high tensile strength and greater load-bearing capacity. Then, plate 3 show a moderate tensile strength and load-bearing capacity because changes or inconsistency of the variation such as less curing time in the manufacturing process could lead to the decreases of tensile strength and the ability to withstand greater load. As a result, the manufacturing process from plate 1 should be chosen as the benchmark for other testing. Meanwhile, plate 2 exhibited the lowest tensile strength and load-bearing capacity among the tested plates. This outcome could be attributed to the bonding quality between the coconut fiber and the matrix, which was carpenter glue. It is possible that the matrix did not fully utilize its supportive role for the coconut fiber due to the changes in the liquidity or elasticity of the matrix over time.
So now, we meet again in conclusion part. In a nutshell, coconut fiber's cohesive nature, through its inherent toughness, makes it a good choice of synthetic fibers in industries such as construction, automotive, and textile. The high tensile strength represents that it can help improve the structural integrity of composites, resulting in higher durability and load-bearing capability. Based on tests on 3 specimens, which is specimen 1, specimen 2, and specimen 3, by using Universal Testing Machine, UTM, it can be determined that coconut fiber has a strong tensile strength, which makes it a potential material for reinforcement in composite materials. The maximum tensile strength for the studies is specimen 1, followed by specimen 3, and the lowest tensile is specimen 2. The different result for the tensile strength and modulus can be caused by variation in layer alignment and adhesive quality during assembly.